Here in the I button and in description box below, you will get the complete playlist of multiple integrals. Welcome to video number 3, and in this particular video we are going to solve second problem based on double integrals. Okay, double integrals. If you go to the playlist in double integrals, you will have videos on these problems. Okay, and in this particular video we are going to solve this problem, which is very important. Okay, so let us start. The question says evaluate integral 0 to 1, integral limit is from 0 to root over of 1 plus x square dy dx upon 1 plus x square plus y square. Okay, here let's suppose I equals to whatever the given in the problem. You need to write this first, that is 0 to 1 integration 0 to root over of 1 plus x square, then we need to write dy dx upon 1 plus x square plus y square. Okay, now here we can see, if you see the limits of second integral, that is 0 to 1 root over of 1 plus x square, here we have x, here we have x in this limit, that is upper limit of second integral. So we can say this is the limit of y. Okay, this is the limit of y. If this is the limit of y, then that means we need to integrate the function, that is 1 upon 1 plus x square plus y square with respect to y first. Okay, so the order of this integration is okay. That means since this is the limit of y, because here we have x present in the upper limit, so we can say this we have to integrate with respect to y first, then whatever the remaining expression is left, we will integrate with respect to x. If this is the limit of y, then the limit of x will be 0 to 1. Okay, here we have x, so we can say this is the limit of y. Here, if this is the limit of y, then this is the limit of x. So we can say x ranges from 0 to 1 and y ranges from 0 to root over of 1 plus x square. Okay, and the order of integration is right. Now we will rearrange this 0 to 1, 0 to root over of 1 plus x square. Okay, then we will write the function first, that is 1 upon 1 plus x square plus y square. Then we will write dy first, because this is the limit of y and we are going to integrate the function with respect to y first. Then whatever the expression is left, then we will integrate with respect to x, whose limit is from 0 to 1. I hope this part is clear to you. Now you need to know one formula. Okay, that is integration dx upon x square plus a square. Okay, the formula is 1 upon a tan inverse of x upon a. Okay, this is the formula that we need to use here. Integration dx upon x square plus a square equals to 1 upon a tan inverse of x upon a. If you compare this with this, you will see here we have dx, but here in this we have dy. Okay, so as per this dx, x square is okay. As per this dy, y square is okay. That means this 1 plus x square, that means the 1 plus x square is what? A square. Okay, this whole part, that is 1 plus x square, is a square. So we can write here a square equals to 1 plus x square. Okay, this is a very important part of this problem. If you compare this with this, okay, here we integrated with respect to x, here we are integrating with respect to y. So we will consider this 1 plus x square as a square. So if this is a square, then what will be a? That is root over of 1 plus x square. Okay, this part is very important as per the context of this problem. Okay, so we can say, if we solve this integration 0 to 1, here we can say the formula is 1 upon a. What is a? That is root over of 1 plus x square. So we can write that is 1 upon root over of 1 plus x square. This is what? This is 1 upon a. Then tan inverse of x upon a. What is x? That is y. Okay, so here we need to write y upon, what is a? That is root over of 1 plus x square. Okay, then the limit goes from, the limit goes from 0 to root over of 1 plus x square. And don't forget to write this dx here, okay, because many of the students forget this dx to write here, okay. Now if we solve this, I mean we need to put the limits, okay. So this is going to be integral 0 to 1 on putting the upper limit, okay. Here we have integrated this part with respect to y, so we'll put this lower limit and upper limit in place of y, okay. So we can say this, that is 1 upon root over 1 plus x square will be treated as constant. I am repeating this once again. Since we have integrated this function with respect to y, so in place of y we will put this upper limit and lower limit. In that case we will consider this part, that is independent of y, that is 1 upon root over 1 plus x square will be my constant. So we can take this out of this equation, that is 1 upon root over of 1 plus x square, okay. Now putting the limits, tan inverse of upper limit, if you put upper limit, that is root over 1 plus x square in place of y, that is root over of 1 plus x square upon this, that is 1 plus x square, okay. Now closing this bracket, minus lower limit. What is lower limit? That is 0. Tan inverse of 0 upon root over of 1 plus x square, okay. Fine. Now we will close this bracket and don't forget to write this dx here, okay. Fine. Now again here we can see integration 0 to 1, 1 upon root over of 1 plus x square, okay. This will be tan inverse of 1, okay, minus tan inverse of 0 upon anything will be 0, okay. So closing this bracket again, we will write dx. Don't forget to write dx, okay. Now we know that the value of tan inverse of 1 is pi by 4. We know that tan inverse of 1 is pi by 4 and the tan inverse 0 value is 0. So this is 0. Now we can say integration 0 to 1, 1 upon root over of 1 plus x square. This is 1 plus x square, and what is this? That is pi by 4. Then we can write that is dx. Now we need to integrate this with respect to x, but this pi by 4 will be treated as constant. So we can take this pi by 4, integration 0 to 1, 1 upon root over of 1 plus x square, then dx, okay. Now you need to remember the formula, that is this will be, this pi by 4 is as it is, this will be log of x plus root over of 1 plus x square, okay. The formula is log of x plus root over of 1 plus x square. Now the limit goes from 0 to 1. Now we need to solve this, that is pi by 4, opening this larger bracket, on putting the upper limit, that is 1 in place of x, log of 1 plus root over of 1 plus 1 square, minus on putting the lower limit, that is 0 in place of x, log of 0 plus root over of 1 plus 0 square. Now closing this bracket. Now solve this, you will get pi by 4 log of 1 plus, this will be 1 plus 1 square, that is root over of 2. So 1 plus root over of 2 minus, this is log 0 plus root over of 1 plus 0 square, that is root over of 1, that is 1. So we can say this is log of 1, okay. Now closing the bracket, we again know that log value, log of 1 will be 0. Log of 1 is always 0. So we can finally say that is the value of I, that is integration, is equals to pi by 4 log of 1 plus root 2, and this is my final answer, okay. Thank you so much.